We demonstrate the LightShop, which is an interactive lighting system incorporating the 2D image editing paradigm. It dramatically simplifies the laborious and tedious lighting process and helps the user generate high-quality and creative lighting conditions interactively and rapidly. As you can see here, the user interacts with the system through direct sketching on the objects and through simple adjustments of the parameters that change the overall look of the scene. It works the same way as any other 2D image editing software such as Photoshop. First, the user specifies regions to be lit with a paintbrush and colors of the light. Then the user inputs a map to a bounding sphere that encloses the objects to create a generalized data map. This data map is partitioned to form clusters by a data clustering algorithm. At this time, the system automatically determines the proper number of clusters utilizing the measurement of cluster validity. Each partitioned cluster is converted to a light in 3D space. With the new inputs, LightShop repeats the process. The illuminated region is wider than that of the previous iteration, and the number of lights is still 1 despite an increased number of user strokes. This wide illuminated region can be divided into 2 regions according to the new user input in a subtract mode. In this manner, LightShop estimates a light conforming to the user input at each iteration. If the user wants to reduce the overall brightness, instead of controlling numerous 3D light parameters for each light one by one, the user can simply change the brightness of the accumulated data map. Note that the effect is global. These scenes are produced by an artist with little experience in lighting. It took between 10 to 20 minutes to set up the lights for each scene. The longest time spent for the computation is 0.374 seconds. LightShop is fast enough for comfortable user interaction. Instead of painting specific areas on the model, the user can provide an environment image. This image is mapped to a data map, and the data map is partitioned to multiple clusters through the same process as other mappings. It is clear that LightShop architecture facilitates easier incorporation of image-based lighting. This is the comparison between the results from LightShop and that from a typical IBL in Mental Ray. As you can see here, the result of the image from LightShop is as good as that of IBL. Using the set of lights extracted from LightShop, high-quality hardware rendering can be run in real time. It requires 10 frames per second, even with shadows.